Welcome to Math 1314. This is section 1.5. In this section, we look at some word problems as they apply to the problems we looked at in the previous section. So let's take a look here. We have a rectangular garden and it covers 90 square yards. So let's see. Here's a picture. Here's a rectangle. And what do we know about rectangles? We know rectangles, their area is length times the width. So area equals length times width. All right, well, I know the area is 90 square yards, so I can fill that in. What else do I know? I know the length is 7 yards longer than the width. Well, I don't know what the width is, so I'm going to leave that as W. But I do know that the length is 7 yards more than that. So they want us to figure out, well, what are the length and the width for this rectangular garden? And if we encounter decimals, we want to round it to the nearest tenth of a yard. Alright, well, let's see how this goes. Well, first off, we have our area formula that I used a moment ago. We have length times width. Well, I don't know the width, that's W. But the length, we can fill in the piece that we do know, and that is it's W plus 7. So multiplying those two things together, W times W, W squared, I get a 7W, and that's equal to 90. Okay, so move the 90 to the right, and I get our equation that has a squared in it. We can use all of our techniques we saw before. We could use the zero product property and factor it, but the numbers are kind of big and I don't think it's factorable anyway, because I would need two numbers to multiply to give me 90, but yet only add to give me 7. And we hate completing the square, so we won't use that. So I'm going to jump and use directly the quadratic formula. So let's see, what do I see? I see A is 1, I see B is 7, and I see C is minus 90. Alright, so I'm going to fill that information in. Okay, here's B squared minus 4 times A times C. Okay. 7 squared is 49. 4 times minus 90 is a minus 360. So I'm really adding here. 49 minus a minus is a plus, and I get 409. Alright, well, that's not a square root that I know, so I take the square root. And for now, I wrote down lots of decimals. We'll round later on. So if I use the plus, minus 7 plus 20.22374, and divide that by 2, I get a negative 6.6. If I use the plus, then I end up with W is 13.612. So I get two possible answers, but the negative one I can throw away because we're talking about a length and a width. So I can't have a negative length in this situation. So my only possibility is W is 13.612. Now if I'm rounding to the nearest tenth, that's the 6. I look at the number after the 6. If it's 5 or more, I round the 6 up to 7. In our case, it's less than 5, so I just throw it away. And so W would be 13.6 yards. And the length, remember, was 7 yards longer. So it would be 20.6 yards. And so that's what we wrote down. So draw a picture, fill in piece by piece the information that we need. All right, in question 2, we have the height of a triangular truss. Well, doesn't really matter what it is. It's a triangle shape. And what do I know about triangles? Well, I know triangles have a height and they have a base. And the area of them is 1/2 the base times the height. What do I know? Oh, I see. The height is 4 feet less than the base. Well, if I let the base be b, then h is 4 feet less, and so b minus 4. And the area of some drywall, that's the white on your walls in your house or apartment, and that area of that triangle is 86 square feet. All right, so I'm going to round this way. And again, here I'm going to round it in the final answer to the nearest tenth of a foot. So here's the area. Here's B. Here's H, which is B minus 4. Now, I don't really want to carry around this 1/2. And so to get rid of it, I am multiplying both sides by 2. And so when I do that, I get rid of it there. 2 times 86 is 172. And for this part, I'm just going to distribute in the b. So it's looking better. And so finally move the number to the right hand side, and we've got this equation in terms of the base. Factorable? Nah, I don't think I want to even try to factor it with this big of a number. So I'm going to jump directly to the quadratic formula. Well, what do I need? I need the a, the b, and the c. So a is the thing in the front, 1. B, which is the number with its sign, is minus 4. And C, the number with its sign, is minus 172. So I fill all that information in. Here's B, B squared, 4 times A times C. All right, minus 4 squared is a positive 16. This piece is minus a minus 168. So again, it's minus a minus, so I'm really adding. And so I get 4 plus or minus this particular square root. All right, so I go ahead and get the square root with my calculator, leave a number of decimals. We'll round later. If I use the plus and the minus, we end up with either minus 11.266 or 15.266. Again, because we're talking about physical items, I can't have a negative length. Therefore, the base is 15.266 feet. Now, what was the deal with the height? Well, the height is 4 feet less, and so 11.3 feet. So again, draw a picture, grab the information step by step. Don't panic, just collect all of the information. All right, in question 3, we have a truck. We have the space in the back of the truck, which is modeled in this way. It has a height, it has a width, and it has a length. And the volume of this truck is length times width times height. Well, let's see, I need a volume. Where in this problem? Oh, the brochure indicates the truck can hold 455 cubic feet. As soon as you see cubic feet, you know they're giving you a volume. So there's the volume. Length is 13. Okay, that's straight away. Just fill that in. Height, what do I know about the height? Height is 2 feet less than the width. So I don't know the height. All right, all I know is it's shorter than the width. All right, so I fill all that stuff in. Now I'd like to reduce these numbers if possible. And it turns out that if I divide everything through by 13 here, then I get a nice number. So I'm going to go ahead and do that. Divide everything by 13. Distribute this part. All right. And so move the 35 to the right. And so we end up with this equation. Well, this is easy enough. I can try to factor this because there are not too many factors of 35. Well, 35 and 1 or 7 and 5. I need a combination that's going to add to give me minus 2. So I pick a minus 7 and a plus 5. That would give me the minus 35 and the minus 2. Let's see, w minus 7 is 0. Move the 7, so I get w is 7. Yeah, that's possible. On the second one, w plus 5 is 0, so that would say the width is a negative number. That's not possible. So let's see, what do I know? I know that the length is 13, that was given. Width we just found was 7. And the height is 2 feet less, so 7 minus 2 is 5. And you can check that if you multiply these three numbers together, you actually do get 455. And so there's the dimensions of our truck. All right, question 4. We want to write an equation about numbers. So let's see. We want to write something about the product of two consecutive even integers is 80. So I'm multiplying two numbers together and I want to get 80, right? So right now I could tell you this is x times y is 80. I'm multiplying two numbers together to get 80. But there's more to it. We want consecutive even integers. Well, first off, even 2, 4, 6, 8, 10, and so on. Consecutive means here's the first, here's the second, here's the third, and so on. But since they put the word integers, I could have negative evens as well. Minus 10, minus 8, minus 6. These are consecutive evens as well. Well, what you should notice is if I start at any one of these to get to the next one, I have to increase by 2. So if x is the first one, then x plus 2 is the next one, regardless if they are positive or negative. All right, so I set up my equation. X times x plus 2 is 80. Distribute, and then move the 80 to the left. Okay, that seems easy enough. Maybe we can factor this, and the answer is yes, because 80 is 10 times a minus 8. And when I add these two together, I do get the plus 2 in the middle. So I grab each piece, set it equal to 0 for each one of them, and solve. And so I get minus 10 and 8. And so we're happy. We think we're finished. But that's not the end of the story. These are not my two answers, because if I multiply them together, I don't get a positive 80. So what's going on? What's going on is the following. If I use the minus 10, then the next consecutive even is minus 10 plus 2, which is minus 8. So there's one's possible pair of numbers. And if I use x is 8, then the next consecutive even is 8 plus 2, which is 10. And so I get two different pairs of numbers for my solution. In the first part here, they want to know what's the equation we used. Well, we used this, or this is the one after we simplified it. And then our pairs of numbers. Remember, both pairs work because all I wanted was the product to be equal to 80. All right, question 5. Question 5 can be complicated, so let's think about this. What's going on? We have a piece of cardboard, just an ordinary piece of cardboard. So let me draw my piece of cardboard over here. Just got this piece of cardboard. What do I want to do? I want to chop out the corners. I want to chop out these pieces that are 5 inches by 5 inches. I want to get rid of them. And then I want to fold this on the dotted line to make a box. As simple as that, but is more complicated. You got to keep in mind, here's my original cardboard. And here's our box. Yes, I know it looks like a box, so shouldn't need to label it, but we're going to label it. All right, and we know we cut out 5 inches. What else do I know? The volume of this box is 1,000 cubic inches. So our basic formula doesn't change. Volume is length times width times height. Volume is 100. The difficulty is the following. We know, where's this part? The length of the original piece is 10 inches more than the width. So if the width is y, the length is y plus 10. Easy enough, right? Now, we are chopping out the corners. And so when I fold this thing up, where this used to be y plus 10, I now have chopped out 5 here and 5 there. And so what I get is y plus 10 minus 5 minus 5. And so the length is really now y. The width, if the original full was y, and I chop 5 out of each side, then the little piece in blue here now is y minus 10. And the height is 5 because that was the square we chopped out of the corner. So again, I know this is confusing. Our original cardboard with its relationship, we chop 5 by 5s out of the corners. And so when I fold it up, my length and width are changed from y and y plus 10. So when I fill all this stuff in now, here's the height of 5, width is y minus 10, and again, this is the width of the box, not the piece of cardboard. This is the length of the box. Alright, I can reduce these numbers, divide through by 5, distribute the y, move the 200. This is factorable, 20 times 10. I just need to fix up the sign so it adds up to give me a minus 10. And so I pick a minus 20 and a plus 10. Alright, so if I set the first one equal to 0, I get y equals 20. That's possible. That's a physical length. And the other, I would get y plus 10 is 0, giving me y is minus 10. But that's not possible because we're talking about physical sizes and lengths. Alright, so what was now my dimensions of my original cardboard? Well, let's see. Let's come back up here. The width of my original cardboard here is y, and the length is just 10 more. And so we solved for y, and so that y is 20. And here the length is y plus 10, which is 30. Now you could also check your answers to make sure they make sense, because remember, I'm chopping out 5 here and 5 there, so I'm getting rid of 10 inches. Well, that's okay. This is 20 inches, so that's still possible to do. So my original cardboard piece of thing is 20 by 20. So just keep in mind, and I keep harping on this over and over, the original piece of cardboard versus the length and the width of the box after you've chopped out the 5 by 5 corners. Good luck with the homework. I know you'll do well. If you have questions, post them to the discussion board or send me an email.